subtraction of surds. Now, the basic rule in addition and subtraction of surds is that they must be similar. Remember, I showed you example of similar surds, but for emphasis, I'm going to write it again. A root n plus b root n is possible. A root n plus n root b is not possible. Now, when you're solving addition and subtraction of surds, before you can add the terms that are outside the root, it means the two terms inside the root must be similar, must be the same. That's only when you can add these terms outside the root. They must be similar. Now, that's why I wrote out this. So our example 1. If I am giving root 32, I am giving root 32 plus 4 root 2. You see, I should simplify this. Now look at the solution. I know if you look at this question now, you might just assume inside the root here is 32, inside the root here is 2. You want to assume it is not possible. But look at this very well. Remember, we did reduction of surds. So we have to first reduce this 32. Is it possible for me to have a perfect square inside 32? Root 32, I can have a perfect square. I can write 32 as 16 times 2. 16 times 2 is 32. Plus what? 4 root 2. Now, 16. What is the square root of 16? The square root of 16 is what? 4. I'll be having root 2. I hope you understand this process. 16 times 2 is this 32. This is the 4 root 2. So I've not changed the question. I only reduced 32 to 16 times 2. Now the square root of 16, because 16 is a perfect square, the square root of 16 is 4, which is what I brought outside the root. Then I'm having root 2, because I don't know it, plus what? 4 root 2. Now these two, I'm having root 2 here, I'm having root 2 here. They are similar, so I can just pick one of the root 2. This is called factorization. I factored out root 2 out. What if I pick out root 2 out? What is left here is 4. Plus what is left here is what? 4. So I'm having 4 plus 4 is what? 8 root 2. So we've succeeded in reducing this question given to us to the surd in its basic form, 8 root 2. Now make sure you look at your questions very well. Look at the possibilities of reducing the question to its most basic form. Check if it's possible for you to get a perfect square as a multiplication of another integer. That is what we did here. I'll take another example. Now we are given this question, 7 root 3 minus root 75. Now let's look at how to solve this. Solution. I am given 7 root 3. This one is in its most basic form. Minus, I have to reduce my 75 and see if I can get out a perfect square in 75. Yes, I can. 75 is 25 times 3. 25 times 3 will give me 75. So I'll be having here as 7 root 3 minus the square root of 25 is what? 5 root 3. Are they now similar? Yes, they are similar because I have root 3 here, I have root 3 here. So I can factorize root 3 out. If I factorize root 3 out, I'll be left with what? 7 here minus what? 5 here. So I'll be having 7 minus 5 is what? 2. So my answer will be 2 root 3. I hope this is clear enough. I'll take one more example on this. Our example 3 is given as root 80 plus root 45 minus 2 root 5. Now let's see if we can reduce this. Solution. Let's reduce root 80 to have a perfect square. My root 80 is the same as what? 16 times 5. 16 times 5 will give me 80. Plus root 45. If I reduce it, it will be what? 9 times 5. 9 times 5 is 45. Minus 2 root 5. This is already in its basic form. So let's reduce these ones to their basic form now. Square root of 16 is what? 4. This is 4 root 5. Plus square root of 9, which is a perfect square, is what? 3 root 5 minus 2 root 5. So we've succeeded in reducing this question given to us to similar surds because all contains root 5. So I can factorize root 5 out. Let's factorize root 5 out. If I take out root 5, I open a bracket. Because I've brought out root 5 here, what is left here? 4 plus what is left here? 3 minus what is left here? 2. So let's finish with what's inside the bracket. 4 plus 3 is 7. 7 minus 2 is what? 5 root 5. That's the root 5 here. So we've succeeded in reducing this question given to us to 5 root 5. I hope with this we've understood how to do addition and subtraction of surds. If the questions don't have similar surds, you just leave the answer like that. You don't simplify further because they are not similar. Now we'll go to multiplication and division of surds. Root 45 times root 28. Alright, let's look at this example. He said we should simplify. Sorry. The question will come and simplify this. Now let's solve this. Solution. The first thing is to reduce to my simplest form. My root 45, I can write it as what? 9 times 5 is 45. Multiplied by my root 28. Can I get a perfect square in 28? Let's see. 2 times 14. 3 cannot go. 4. No. 6. What times 4 to give us 28? 7 times 4. 7 times 4 is 28. Alright, we've succeeded in reducing these two to get perfect squares in two of them. So let's see. The square root of 9 is what? 3 root 5 times the square root of 4 is what? 2 root 7. Now please look at this properly. Look at it properly. We are not doing addition and subtraction, so the term similar surd doesn't play here. Remember the first rule of surd. When you are having two surds multiplying themselves, you can actually bring in these two into a single square root. So I can rewrite this question as I take these two together, 3 times 2 times I put what is inside the root, 5 times 7. This is 5. I pick these 2, 5 times 7. This 2, 3 times 2. My 3 times 2 is what? 6. Root 5 times 7 is what? 35. I cannot reduce this further because there is no perfect square that can come out of 35. So I leave my answer this way. This is the simplest form of this question. We'll take another example to explain further. 50. Now I am given this. Remember in our second rule of surd, if I'm given this, my solution, I can decide to reduce this. I can decide to write this question as what? 24 over 50. It is allowed from the second rule of surd. I can divide these two. If I divide here, I'll be having what? 12 over 25 root. I can write it as what? I'm sure you understood what I did here. I divide this by 2 to get 12. I divide this by 2 to get 25. That's how I arrived at 12 over 25. So I can write this as root 12 over root 25. Let's go further. My root 12, I can have a perfect square in root 12. Root 12 can be written as 4 times 3 all over the square root of 25 is an integer. The square root of 25 is 5. So we only have this here, which can be reduced further. The square root of 4 is known, is what? 2 root 3 all over 5. So our answer is 2 over 5 root 3. So we reduce this question to 2 over 5 root 3. This is how you leave your answer. Please take note. You can see how I was able to reduce this. Some other persons, let's see how another person might be able to solve this and see if we'll arrive at the same answer. Let's look at this. I'm still taking the same question, that's 24 over 50. Without reducing this, I want to just write out the product in terms of what? Perfect square. 24 is the same as what? 4 times 6 all over 50 is the same thing as what? 25 times 2 root. So this is the same as having this square root of 4 is 2 root 6 all over the square root of 25 is what? 5 root 2. Now look at this. I have my 2 over 5. In our rule of Surds, I can decide to take these two together as what? Square root of 6 over 2, which will give me 2 over 5. How many times can 2 go into 6? 3. So you can see we got the same answer. So either you follow this method or you follow this method. Anyone will still arrive at same results. Alright students, I'm sure so far you've been able to understand how to solve questions involving addition, subtraction, multiplication and division of surds, knowing the rules of the surds. In our next class, we shall be looking at conjugate surds and how to solve questions involving conjugate surds. Thank you very much, and please click on subscribe when you go to my YouTube channel and leave your notification on so you can always get updated when our new teaching video drops. Thank you.